In this section, we're going to talk about logarithmic properties, and we're going to be adding to the properties that we already learned when we introduced logarithms. So, said that kind of funny, but it's logarithm. There we go. Let's rewrite the properties we talked about before. And I do want to kind of name them as well, just so that we have a reason for remembering where they're used. So there was the two inverse properties. And that occurs based on the fact that logarithms and exponentials are inverses of each other. So those properties are, if you have the log base b and you take the log of an exponential function with the same base. All right, I'm going to put parentheses. Maybe it's, raised to the x power, then that's going to equal x. The other one is if you take a exponent and in the exponent you have the log of the same base, then those cancel and we're left with x. Then we have the exponential property of logarithms. And that one is important and we use it a lot with solving. That is when you have the log of something with an exponent, you can bring the exponent to the front. And we use that quite a bit. And then the last property is the change of base formula, which we didn't really use very much. And in fact, the change of base formula has some applications, but it's not as big of applications that you're going to see now. It's really more later on. The change of base formula says that if you have log base b of x, you can use any other base by writing it as a division of x over the new log over b. All right, so those are the properties we've already learned. We're going to add two more properties, the sum and difference properties. So the sum property looks like this. If you have the log base b of x, and to it you are adding log base b of y, so they have the same base, that actually becomes, or can be rewritten as the log base b of x times y. So an addition of logs really becomes a multiplication of a single log. And then the difference property, you might guess, if you're subtracting the two, most people would know then if adding them is multiplying, subtracting them usually then means division. So those are the two properties we're going to see in this section. Now, really quick, it kind of helps to understand that when we're talking about logarithms, we're really talking about exponents. So when we're talking about two things being added, really meaning multiplication, they're actually referring to the idea that of exponents. So it's really building on the property. The first one in particular is building on the property that if you have b to the a and you times it by b to the c, that becomes b to the a plus c. So a multiplication between exponents of the same base ends up adding the exponents. And it can be kind of shown that if you were to say that b to the a equals x and b to the c equals y. All right, if you say that, then if you take the log of x plus the log, of y, that's really taking the log of b to the a plus the log of, b to the c. And I should be using the same base. That's why I paused there for a second. So actually these should be log base b, log base b. This is log base b, log base b. And then that becomes a plus c. And what we kind of started with was adding the logs of these two x plus y. But if you do the log of b x times y, that's the log of b to the a times b to the c, which can be written as log of b times, of b to the a plus c, which also equals a plus c, using the inverse properties. Both of these are using the inverse properties. So what we have shown is that this ends up with a plus c, but so does this. So they're the same. They're equal. So that's one way to kind of show that this property works out. But really, it's building from the idea that we're really displaying exponent properties. That's what logarithms are really secretly doing. Okay, don't get hung up on this. That's just to kind of show you where they came from. Really, we want to look at how we can use this. Before we do that, we're going to do some practice and play with the two new properties. So first thing we're going to do is we're going to write this series of logs as a single logarithm. We can do that because they're all log base 3. So we're going to combine the two new properties, the sum property and the difference property. So let's start with the sum property. So log base 3. So since it's an addition, it's really going to become 5 times 8, which is 40. So that's 40. And then we can combine these two, this subtraction as a division. Log base 3 of 40 over 2, which then becomes log base 3 of 20. And there we did it. We wrote it as a single logarithm, nice and clean. And these two are equivalent. If we were to plug them into the calculator, they'd come out with the same answer. Okay, evaluate this without a calculator by first rewriting as a single logarithm. So again, they want us to kind of play this logarithm game using the exponents, using the addition rule, and we're going to use the exponent rule. And the reason we're going to do that is I see that we have a 2 out in the front. So we can bring that 2 up as an exponent for this first log. By the way, this is log base 10. I see that it's log base 10. So keeping that in mind as we kind of do this. So 5 squared is 25. And now I can bring them together as a multiplication, which, by the way, I don't need to show this step. I can just multiply them. I don't know why I am. I'm just being careful. Okay, and then log base 10 of 100. This is what we're technically looking at. That is base 10. That actually can be simplified if we think of 100 as 10 squared. And that means we can use the first property, and the log 10 of 10 cancels, and we're left with 2. So this simplifies to 2. And then in this one, they want us to do the opposite. This time we're going to rewrite it as an expanded version of logarithms, multiple logs with additions and subtractions, and we're not going to have any exponents. So we're going to basically use the exponent rules to spread it out. I'm sorry, the logarithm rules to spread them out. Okay, so first thing I'm going to do is I'm going to tackle the division. So I'm going to put the numerator x to the 4th y as its own log, and then the denominator, oh, that's a 7. There. All right. Now I'm going to break up the multiplication. Not log, natural log. There we go. I typically use the curly L when I'm doing natural log just because it helps me tell the difference between 1s and L's. And then I'm going to bring that 4 down, that exponent. And there we go. Now, this type of problem where we're expanding into multiple logarithms is actually really useful in calculus. There's an application of this in calculus, but we won't really see much beyond this, just practicing expanding into multiple logarithms. Okay, so that's fine and dandy. Let's see where it's useful to us. So this is an example from chemistry that has a formula for the pH balance. Now, the pH balance is a logarithm. I do want to mention, by the way, logarithms didn't exactly come from the need of inverses. I teach it that way because it's a nice, easy connection to a concept we've already done. But logarithms actually existed in multiple ways to help with lots of different things. They helped with calculations and all sorts of science applications. So it is not just inverses. So this application in chemistry uses a logarithm to model pH balance. Okay, so let's see. If the concentration of hydrogen ions in a liquid is double, what is the effect on pH? So because we kind of need to label some things here, it's a little bit odd. H plus is a way of talking about the concentration of hydrogen ions. So I'm going to give it a different label. I'm going to call it C. So let's say C is the concentration of hydrogen ions. And instead of that H plus, I'm going to plug C into the pH. So that's going to be negative log of C. Just looks a little bit nicer. I don't need the parentheses. Log of C. Okay, great. So now if we double the concentration, that's just what this is saying. If the concentration of hydrogen ions in a liquid is doubled, what is the effect on pH? So if I double it, that means I'm literally looking at 2C. Okay, now this one I'll put parentheses around since they're both part of what we're looking at. Okay, and you're like, all right, that's interesting. So what I can do is I'm going to try to compare this to what I have normally. And what I'm seeing is that I can use the log properties to break up the multiplication. I mean, honestly, that's like the only thing I can do right now. So I'm going to do that. I'm going to break up that multiplication. Now, technically, this negative is outside the whole thing. So it does need to be distributed in. And log of 2, that's like a number. All right. In fact, get your calculator. Let's figure out what that number is. So taking the log of 2, so negative log of 2, I come up with negative 0.301. I'll just do 3 decimal places. That makes sense. Now this was the original pH, this log of C. So this was the original pH that we were working with. So what we are seeing is that the original pH, which I'm going to just label it like that, original pH, that whatever that is, we're subtracting 0.301 from the pH level. So that is what the effect of doubling has. So it subtracts the pH by, or let's say decreases. That's a better mathematical word, right? It sounds better. It decreases the pH by 0.301. And there you go. That's what happens when we double it. And in the next video, we'll go ahead and talk about using log properties to solve equations.